ladies and gentlemen, it's a pleasure to be the moderator for this session. We are in room A, according to the program. I was told this is room A, and we will have 5 presentations. In this room A, first we have an invited speaker from Malaysia, and the time allocated is 30 minutes for this presentation. And then we have 4 more presentations with 15 minutes time allocation. And time allocation means we have the presentation itself, and then we have some minutes of questions and answers. So please listen carefully enough and formulate very good questions. This is a big opportunity to ask questions. May I invite the first speaker from Malaysia, Mrs. Tahir, well-known scientist from UPM in Malaysia, having been worked on various aspects on oil palm, and she is going to present today a very interesting topic on plywood from oil palm, improvement of quality of plywood for marine applications. And you should know that plywood from oil palm is one of my favorite products, so I'm looking forward to your presentation. You have altogether with question and answers 30 minutes. Please, the floor is yours.
Let me just test this one first. Oh, sorry. Thank you, Ano. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to everybody. My name is Farida. I'm from the Faculty of Forestry and Environment, Universiti Putra, Malaysia, and I'm very honored to be here as an invited speaker to speak on my experience in this work. Yeah. So upscaling production of marine grade equivalent MGE plywood from oil palm trunk. So this project is, let me just go to this side. Maybe you can hear me? Yeah, okay. This project is funded by the Ministry of Plantation Industries and Commodities Malaysia under the Malaysian Timber Industry Board. And the project is owned by the Malaysian Panel Products Manufacturers Association, MPMA. I'm one of the researchers in the team, together with the Forest Research Institute Malaysia. So we developed the product together with the with MPMA, and our collaborators is Fiber Development Center, MTIB, Biomass Technology Unit, MPOB, Malaysian Palm Oil Board, and our industrial partners are Plus Intervest Sdn Bhd, a plywood company, and ICA Malaysia Sdn Bhd, an adhesive company. Yeah. Before I talk about the project, it's just a short snapshot on the palm plywood. So in 2008 to 2018, we have started making plywood from oil palm trunk. As you know, the trunk is just like date trunk, but it is quite soft compared to the date trunk and coconut. So the properties is very much different than coconut trunk and also wood. Yeah. So in the first phase, what we did was just peel and make a plywood out of it, of which we need to put wood veneer on the faces so that the plywood is good, yeah, can be used. But later on, since 2015, we have been trying to enhance the properties so that we can sell the plywood into a higher product. So that's why we call it we want to call it a marine plywood, but we cannot call it marine plywood because it does not have the full characteristic of marine plywood, because marine plywood have got its own characteristic. So that's why we call it MGE, equivalent plywood to marine. Yeah. Okay, the presentation will be, first I will just introduce a bit on what is marine plywood and why we want to go into marine, and then a bit of verification study on the parameters. Then I will bring you all to how we develop the treatment facilities, the upscaling production of the plywood itself, and what are the performance of the MGE plywood. Okay, marine plywood, as you know, among all the plywood in the world, can I just use this one? Among all the plywood types, marine is the highest type, and you can sell it at much higher price compared to the ordinary plywood. Why? Because the performance is much better, the quality is much better, the quality control is more stringent. Yeah. So, but not all timber species can be used for marine plywood. There are only durable species, naturally durable species that can be used, which means you don't have to trade it. You just make it into plywood, then you can use it for more than 10 years. So that's what it meant. And for OPT to become marine plywood is, right now, is impossible. It's impossible, yeah? So, but the price is very good. If you look at the price of a 4 by 8 feet panel, the price is between 35 to 100 USD, compared to if you buy OPT plywood at the current quality, the maximum you get is $20 USD per panel, 4 by 8. Yeah, so if we can upgrade the quality of this OPT plywood into a marine grade equivalent quality, you are talking about this kind of price, 35 to 100 USD per panel. Yeah, okay. So as I said, let me see. The requirement is very stringent. It has to be water resistant, pliable, impact resistant. Surface finish must be good. It is used for outdoor and for long-term use. And usually it is made from hardwood, because the only hardwood can meet this criteria. So it's quite impossible for OPT to, if you think about this. So if you compare between marine grade plywood and this is the one that you are making. So marine grade plywood must have a naturally durable, naturally resistant to decay wood species. Yeah, but for our open trunk plywood, that if we were to convert into MGE plywood, it is not naturally durable, so we have to do some treatment. So the innovation is on the treatment. Okay. So how do we change from here to that? Yeah, see, it looks more or less the same, but you can see slightly different quality on our current palm plywood compared to the marine plywood. Yeah, so this is what $20 per panel, and the other one is $35 to $100 per panel. So that is what we want to go. Okay, so basically what we do is we conduct a phenolic resin treatment using a phenol formaldehyde resin, put it in the vacuum, take out the air, and then flood in the resin. Yeah, and make sure the resin bark penetrated into the woody material, and then we vacuum out. Then you get your material. So this is basically the principle that we are doing. So the objective of this presentation, one is to verify processing parameters, and then we establish a pilot scale facility, which is the resin treatment facility and also production of the plywood, and finally we evaluate the performance of the MGE plywood. So the laboratory experiments, we start with a small scale under laboratory experiment, impregnating the veneer with resin, and then cure the treated veneer, and then we press it into, consolidate into plywood, then you get your plywood. So in the laboratory, it's all well and good. The properties is much better than we expected, and we can even make 100% OPT. We don't have to put in wood veneer inside it. Yeah. And then we tested based on the international standard. We did also on the durability study, because marine plywood must have the durability scale, decay resistant against fungi and also termites. And this is what we get. So the density of this laboratory based, the density is about 650, the modulus of elasticity is about 3.1 gigapascal, MOR is about 21, not as good as we need to be, and the dry shear is about 1.52, is good enough, but for the MOR and MOE, we need to further improve through densification, so that we can have better strength of these two. And then if you look at the shear, that is the bonding, 1.47 after 24 hours soaking. It can withstand up to 1.47 megapascal. The shear after 6 hours boiling and 4 hours drying, 1.22. And thickness wearing is less than 5%. Water absorption, that is not really a problem, 60%, nearly 60%. So, and the decay resistant, it is class 2 durable with the treatment. And the termite resistant is class 1, very durable with the treatment. So, in a way, some of the properties of the marine has already been met, except for the strength. Yeah, except for the strength, the rest has already been met. Okay, now come to the big thing, the installation and commissioning of treatment process and mitral. And we are talking about big scale with a cylinder, pressure cylinder of about 15 meters long, yeah, and diameter of nearly 1,800, about 1.8 meters. Yeah, the diameter is about 1.8 meters, and this is 15 meters. So it's a big cylinder equipped with the resin tank, the storage tank, and everything, and also filter system we install to make sure that the vacuum, the vessel is in place. Yeah. Okay. Then we do the resin impregnation process. Yeah. So basically, these are the SOP that we produce, that we used in order to impregnate the resin into the veneer, And if you look at, if you look at the veneer, these are the veneers that we used to impregnate and put it in the vessel and impregnate it inside there. Yeah. So this is after impregnation took place. We take it out. These are all treated, phenolic treated veneers that has already been treated in the cylinder. Yeah. Okay. And this is the most challenging sequence that we have faced during the project. One of it is that our veneer dryer, this is the one that we use currently, is not that suitable for the phenolic treated veneer. Why? Because once you treat the veneer, it becomes a bit soft because it's very wet. Yeah, you are talking about moisture content about 30%, 40%, so it's quite very soft. So when you put it in the veneer dryer to dry it, yeah, to dry it into 20% moisture content, it tends to be twisted by the roller. So we have to make a modification. Instead of feeding this way, we feed it in the other way, to on the other side, this side to that side. Yeah, so that we can avoid this. So that is a challenge for us to do. Okay, so some of the treatment process attributes, we require 4 days. 4 days to finish the whole process. Day 1 is to do some veneer sorting, and then the second day we do the resin mixing, fastening, prepare the veneer on the trolley and feed it into the vessel. And then day 3, the treatment process. The process took about half an hour, less than half an hour. But we have to leave it there for another 2-3 hours or 4 hours so that sufficient resin being penetrated into the wood. Yeah. After that, we take it out from the vessel. So on the 4th day, we need to dry all the veneer using whatever. It can be from using kiln drying, can be using roller dryer, whichever is suitable. But in our case, we use roller dryer to make it faster. And the volume of veneers from the vessel, we treated about 17.65 cubic meter. We use 30% resin solid, uptake about 20.67%. The recovery of the resin is about 79%. So we only use about 21%, less than 21% resin. The rest you can recycle. And then we also have rejects due to cracks, splits and all that, about 25%. So remember, this is the first time we are doing it in a big scale. So we are still making try and error, and the reject is a bit high, 25%, no doubt. Number of treated veneers dried per day was about 250 pieces. Yeah, after we sorted out what we can use. Yeah. Number of workers is about 4 person to do all this work. Okay. So this is some of the analysis that we did on the bundle. So these are the bundle. We have 13 bundles here of different species, yeah, to fill up the vessel. And we found out that the resin uptake, whether you put here or on the other side, is not, it does not vary much. Between 14.9% to 15%, 17%. So not much. But the higher the stack, the less is the resin penetration. You can see here, the top here, when we sample out, the top here had only 3.2%, 2.9, 2.4. The middle here only get about 6.4, 6.9, 6.3. Only the bottom have got 14 to 17%. So it's very important when you want to fit in the veneer inside the vessel, not to put as high as much. Yeah. So this is very, very important and something for us to improve later on once we try it. And some of the attributes on the how much resin we use, amount of resin needed to fill up the tank is about 29 cubic meter or 30,000 liter, because the vessel is big. The resin added for the first pressure is about 1.6 cubic meter. Resin after second pressure about less resin is needed, 0.49 cubic meter. Amount of resin added up to third pressure is about 160 liters. So 3 phases of pressure with different amount of resin being penetrated into the wood. Yeah, so the total amount of resin that we use is about 32,000 liter. Yeah. Amount of resin recovered after treatment is about 25,000 liters. So you only use about less than 20%. Yeah. So resin consumed is about 20.6%. So why I mentioned about the resin, because of course you use a lot, but the treatment only take about 20% of the total resin. So about 80% more or 70% more you can recycle for the next batch of treatment. So some treatment features, we only use 21% resin. Total time required to conduct a full treatment is about 4 days, depending on type of dryer you have. The additional resin mixture has to be in standby because the amount of resin being sucked into the veneer, the wood veneer, is sometimes different. So you must make a standby resin when you do the upscaling. And then our veneer bundles need to be secured, because when you put insert the pressure, the veneer tends to fly over in the vessel. So you have to tie it up tightly so that it will remain on the trolley. Yeah. And then, as I mentioned earlier, using roller veneer dryer is not that suitable for this type, for the treated veneer. drying of treated veneer need to be carried out immediately after going out from the vessel. So you have to do this within 1 week after you do the treatment. You need to dry it off. Yeah. So the wood weight percent gain, yeah, the resin, how much resin get into the wood are different depending where you put the veneer. Okay. Okay, this is mill production of marine grade plywood. We had installed the hot press, the 10 opening hot press, yeah, 4x8, yeah, for 4x8, and we made the plywood manually and fit in the hot press. We had two methods. One method, method A is only 3 steps: assembly of the veneer, hot pressing and conditioning. Method B is we add a little bit more glue spreading. The normal process for plywood, add glue spreading, and then the rest is the same. So we have 2 methods. This is how we made the veneer. You can see the distribution of resin is much more on the at the edge compared to the middle. So that is where the weakness is when we test the plywood. Okay, these are the properties that we get. These are the parameters that we use. We have 5 types. We came out down to 5 types of plywood with different method, different drying condition, moisture content, and different composition. Yeah. Yeah. Some important features of the hot pressing. It is crucial to make sure that all the dried treated veneers being used within a week. And then maintaining the moisture content of the targeted to less than 20% is very, very important, so that you will not get delamination. And finally, handling of treated veneers during assembly and feeding into the plate pose a big challenge because it is soft, as I said, so it has to be carried out carefully. Yeah. Okay, now come to the performance, or what are the performance. We did all that, so the most important thing, what do we get from that? So if you talk about marine grade plywood, we are talking about weather and boil proof. It has to be boil proof, so this we can get, yeah, because we use phenolic, so we have no problem there. And it has to be durable from termites or fungi. This is also doable. We have achieved that. It has to be, the veneer has to be good. Voids, cracks are to be avoided. But using OPT trunk, it is very difficult. So that is something that we can't achieve yet, because that is the nature, the natural thing about OPT. You know, unlike dates, it's a bit dense, so you get a better surface properties. Compared to OPT, we get a very poor properties. So this is what we are trying to do by treatment with the phenolic. Hopefully, it can improve the properties and get the acceptable strength. Yeah. So these properties play a role in getting an acceptable strength. Okay, so where we use international standard for our properties, and these are the 5 types of plywood that we made. A and B, 100% all palm veneer. C, we put rubber wood veneer on the surface. D, we have 100% rubber wood to compare them. And E, we have the same as C, but we put in additional glue, so that to see whether we can have a better strength. And then we compare that with these 2 commercial available OPT plywood and also rubber wood. Yeah, OPT commercially have rubber wood on the surface, and rubber wood we have 100% rubber wood. Okay, so if you look at that, so these 2 are commercial. These are this is on the density. So all the phenolic treated have more than 800 kilogram per cubic meter. So very, very dense because of the treatment compared to the untreated, the commercial one. Yeah. And if you look at the bonding properties, which is very important in marine plywood, you can see that very inferior if you use 100% OPT, but you get quite a good one if you use rubber wood on the surface or other wood veneer on the surface. If you compare with the commercial, and of course rubber wood is always good. That's wood, yeah. So they are much stronger. So there's no question on that. But if you look at the wood failure, you can see that the wood failure of the oil palm, 100% oil palm, and some of the other oil palm are very high. This indicates that oil palm trunk veneer, the woody material, is not strong. So that's why when you put a shearing force, it will break. So that's why the failure is very high for all the plywood having OPT, unlike rubber wood. Yeah. So this is on the shear after 24 hours. When we soak it in cold water for 24 hours to see whether it can stand water or not, we can see that the first AB failed, the 100% oil palm, but we have all these C and E pass, and all the rubber wood of course pass, yeah, and the commercial OPT failed. So in a way, we have already improved the bonding after 24 hours because it passed compared to the commercial one. Okay, this is after 72 hours soaking. You can see on the C and E, this is containing OPT with the surface rubber wood are still intact. Yeah, the commercial is very much lower. It cannot withstand 72 hours, but of course rubber wood can withstand as much. And if you compare all the properties against BSEN 3142, that is for bonding shear, you can see that A, B, C fail after 72 hours. D, rubber wood of course pass, but E, the one with additional glue, pass. You have a 90% wood failure here. And OPT commercial fail. Yeah, this also suggests that there is some improvement in the by using the treatment. So mechanical properties, bending parallel to the grain, same thing. If you look at 100% OPT, of course lower than 20 megapascal. But if you look at C and E, this is containing OPT is high and much higher than the commercial OPT. Yeah, but of course rubber wood is always higher, and treatment, these are all phenolic treated, are much perform better than the untreated. Yeah, the modulus of elasticity, same thing here. Okay, somehow the treatment increase the modulus of elasticity, that is the rigidity of the material very much. A bit more. Okay, this is on the bending perpendicular, or both are lower. And this is the hardness. Hardness, if you look at the treatment with phenolic, give you much harder material compared to the commercial. So formaldehyde emission, this is the most important thing. You don't want formaldehyde emission to be increased, and all the treated veneer has less than 0.1, which is, if you look at the formaldehyde classes, it is what we call 4-star. And for commercial, this is very much higher. Yeah. So in summary, MGE plywood made of OPT veneers as core and rubber wood as face need additional glue spreading to pass bond requirement for 72 hours bonding. So that means for marine plywood is good because we passed that. Only MGE plywood with rubber wood face and back has high MOR MOE. So we still need the rubber wood or any other wood veneer on the space. 1 minute, Anu. Okay, Jengka hardness of the phenolic treated is good. Yeah, and MGE plywood having formaldehyde emission, very low formaldehyde emission is very commendable. Okay, now where are we going to use this MGE plywood? So I just put, this is the table that I get from this standard ISO 16894, wood-based panel for oriented strand board. We know that we use OSB for sheathing, plywood sheathing, flooring, roof and also wall. And this is the requirement for OSB, yeah, oriented strand board. And if you compare these values with our values, we can meet this anytime. Okay, that means our MGE plywood, even though it's not perfect yet, we can still use for class heavy duty load bearing OSB to replace this OSB for flooring, walls and roofing. Yeah, as I said, you compare that with this value, ours is much higher. Okay. And some interventions, if you were to use the process, if you want to carry out the process, the treatment process, on the treatment process, we have to retain veneers in the vessel of additional hours after the pressure is released. This is to make sure a sufficient penetration of the resin. The drying time of the veneers to be carried out within as soon as possible after we take it out from the vessel. The drying method has to be improvised so that you can dry the treated veneer much faster. And of course, you need a stringent quality control in order to make sure that your your MGE plywood, it will perform as what you want. Yeah. Okay. With that, thank you.
Thank you, Dr. Paria. Are there questions? We have some minutes because the invited talk gets a few minutes more. Yes, please.
Second question, using phenolic formaldehyde, it's not good for human health. Okay, what can you say about that?
Okay, the first question is on the moisture content. As I said, the method of drying the treated veneer is very important. As what you can see, we use veneer roller dryer for faster drying because you feed in, then it goes outside, then you get about 20% moisture content where you control the humidity and also the temperature. But you can also kiln dry it. Put in the kiln dry oven, put it inside, then you arrange it in such a way, you stack it, and then you can dry it as well. So that is the best way of doing it. And you just can use moisture meter to check, make sure it's 20%. Just a normal moisture meter. Okay, the second question, whether phenol formaldehyde is toxic or not. Well, we use phenol formaldehyde in many instances for coating, for making composite and so on. It is not like aminoplast, like urea formaldehyde, melamine urea formaldehyde. It will emit formaldehyde. That's why we tested on the formaldehyde emission. It is less than 0.1 milligram per liter. So that means, and it is categorized as F4 star, which is very good. Yeah.
Thank you.
Okay. One question more. Yes, please. The microphone, please.
Hello, I'm Home Dakala from University of Portsmouth, UK. Thank you so much for your presentation. You have amazingly achieved so many tick boxes for marine application of plywood.
Thank you.
My question is related to previous question. Is obviously you were busy making more important properties, measurement, and evaluation and validation. That is fair enough. I was wondering what happens to microplastic release when you use this marine environment, ecotoxicological aspect of especially phenolic resin, and what happens to marine species. Perhaps maybe there is not so much worry at this moment, but at some point you will have to think about it.
Okay. Well, if you know, phenol formaldehyde is a thermosetting resin. So as any other thermosetting resin, one is cured, it becomes very hard and untouchable. You can't even break it up. You need to use a hammer, a big hammer, in order for you to break it up, because it's a thermoset resin. It doesn't release upon high humidity or temperature, not like the aminoplast. So if it is properly cured, so that's why it is important if it needs to be properly cured when you use it.
Thank you. Thank you very much. We have time for one more question. Not from the auditorium, then I may ask the question.
Okay.
What is the resin loading, the optimal resin loading of the wood? How many percent?
The optimum resin loading, you mean the weight percent gain, eh?
Yeah.
About less than 20%, but in our case, it's between 14 to 17%.
Okay.
At 30% solids content.
Okay. But there's still the problem of some properties of the oil palm wood, which is the low density of the parenchyma cells, and this ends up in the very low shear properties of the panels you showed us. So do you see a chance that even the shear properties could be improved by maybe more resin?
We tried higher dosage of resin. It improves much more. We get something here. We get something like 1 point something. We can get even up to 3 point something megapascal. But of course, the more the resin you put in, the heavier denser the material. So we want to reduce on that. Yeah.
Okay, thank you very much. So we thank Dr. Paria very much. And I would like to give you a certificate of application for your talk. Thank